hate when they say it's going to be good, so now your expectations are way too high. I just come in cold. Good morning. It's so nice to see technology in the South. I grew up in Atlanta, and never in a yes, the South represents in technology. So it's nice to be here. So we're going to talk about, we talk about open source a lot, and we talk about the source code. And one thing that I found through my career that's even more important and more powerful than the source code is actually the knowledge. I look at source code these days as just the serialization of ideas. Right? Someone figures out how to do something, and then we teach the computer how to replicate it. So to me, the source code has become less interesting over time because there's so many programming languages, but the ideas are what's important. Unfortunately, not everyone can read source code. We have this illusion that everyone can learn to code, or everyone cares to code. I actually find it pretty boring these days if I don't have a great idea. How many people like fixing bugs? Boring as hell. Like, you should be a programmer when you grow up. It's like, that's what you do? No thanks. So we have to have something a little bit more inspiring. So hopefully my laptop shows up. So we're gonna walk through this new world of what development should be like. One that's not as boring, I hope. Oh, we see terminal. I don't have any slides. Is that okay? If you get nervous with this terminal, don't worry. We're going to type stuff today. So I went to the after party, and I noticed there's a lot of people that are new grads that are here just learning about this stuff. If you're a new grad, raise your hand. Oh, there's not a lot of you. You're lying then. Or maybe all the new grads were at the after party. Rookie mistake. Never go to the after party. But I was one of those people that didn't learn to code until around 24, 25 years old, okay? A lot of people believe that you have to learn early to be good at this stuff. I actually think the ideas are more important. The tools are what matter, because the tools change all the time. Be honest with yourselves really quickly. How many people feel that their skills are starting to get a little outdated? Yeah. You hear all this stuff about containers, distributed systems. And unfortunately, a lot of us will dismiss this as hype until it's too late. Then you look up, it's the new norm, and then you feel a little uneasy. The truth is, most of the things that we learn are just slight improvements over each other, right? So one thing I'm going to do to show everyone at ease around this container stuff, and it's the ideas that matter here. So we're entering this new world of computation. It's going to be a little bit different than the one we know. What's the world we know? The world we know is you write some code. Anyone tell me what programming language this is? Just shout it out really quickly. I think you know me and you're guessing. Also, you saw the .go extension, okay? Kind of gave it away. So this is the Go programming language. There are so many other programming languages. How many people have ever been a sysadmin before? Okay, we're going to talk about that in a minute. So developers write code, and we believe the world is this easy. Something like this: go build your app. Look at that. For those that are new, I compiled the app. This is a compiled language. And I built a binary. These are things we take for granted. Now, with this binary, I'm just going to run it on my laptop. Watch out. This is so simple. There you go. I have this binary. Now, watch. You can hit it. Here we go. Curl. It's going to be amazing. You remember writing your first program? You're like, oh, I did that. No matter what people say, you're a developer at this point. Okay? All right, so we have this hello world thing. And also as a developer, you believe the world is also this simple. We need to run this on a server. Okay? Now, DevOps is about to be born right now. So to get this on a server, I can't just take this binary that I have and run it on the other server. So what I have to do is compile it. So this is called cross-compiling. Have you ever done this before? Your programming language may not be as friendly. So we're just going to do hello world, and then we're just going to build that thing again. And then this is what you do. Now, this is how we used to do it before all this distributed computing and cloud stuff. You take this binary, and then we're just going to copy it to a server. Right? I'm just going to copy it to the server over my tethering plan. AT&T is like, what the hell are you doing? Woo, we hope it works. All right. And then you log on to the server, and you start it. This is what we're doing about 15, 20 years ago. Now, some of you are sitting there, it's like, damn, this is what we're doing right now at my company. But it's all right, just pretend, okay? Pretend that's not the case. And you take this binary on the server, and then you run it, okay? It's really simple, okay? Let's just do hello world. Now, I know some of you think it's like, what the hell are you doing? Do you know the IT industry has spent probably $1 trillion doing this? $1 trillion doing this. And have you heard of this thing called on-call? For those of you that don't know, around 2:45 a.m., your phone will ring. It's going to ring because this server will go down. And you're going to wake up and you're going to put on your heroics and you're going to do this. So now at this point, you're a badass, okay? And then your company goes to a conference and they come back and they say, we're going to the cloud. And then all the machines show up. So you're like, oh yeah, I'm going to script it. I'm going to automate. How many people think automation is good? Yeah, all the hands go, wow, automation is perfect. I could just automate this whole process. Build a binary and copy it to all the machines. Automation and configuration management was born. There's a problem. This doesn't solve the on-call problem. It probably increases the on-call problem. And people have a hard time understanding the difference between automation and orchestration. Right now, we take these binaries and we are very deliberate about where they go. So let's look at the difference between automation and orchestration. And the way I like to explain it is with Tetris. Anyone ever play Nintendo? Hell yeah. My mom didn't know the importance of Nintendos like it was very important. So this game of Tetris, I'm going to explain the difference between automation and orchestration. So automation is good. For all the new people, one-click deployments is the holy grail for our industry. You click the button once, fully deployed, okay? I'm going to show you what that looks like. You got to do it fast, too. One-click deployment. Click, fully automated. Look at that. You know what I mean? It's on autopilot. Like I can deploy to any server. Like, this is not what you thought about. You're going to lose. Because the way we write these scripts, you have to know every single thing that will possibly happen up front before you write the scripts. So we've done all of this automation, but it's still painful. 10 years in, it doesn't work. On call. And then we even got startups like PagerDuty. How do you build a whole startup around on call? So remember, the thing is we have to learn. This is not just about writing code and open source. There are ideas of how to solve this problem. So the other part of this whole open nature is about sharing ideas. One of those ideas, where I work at a place called Google, we also had very similar problems. In the early days of Google, everyone thinks like Google has figured out all this stuff. No, we have not. The only thing Google has is all the problems, not necessarily all the solutions. So we get to experiment a lot more than most people would because we get this exposure to things. So one nice thing that I like to see in the open source movement or this open movement is this idea of sharing ideas. Here's how we manage lots of these little tiny machines in a way that we can reduce being woken up for basic failures like a server going down, okay? So when you read all of this stuff, then projects like Kubernetes just become implementations of this idea. So when people ask me, how do I go about learning this new stuff, honestly, the idea is more important. So for me, I understand the ideas. Any new open source project that comes out, I get it. It looks a little bit like that. It may have a different implementation detail. So let's talk about the implementation details. How many people have heard of containers? Keep your hand up if you think it's just hype. It's legit. The analogy I like to use to explain why we have containers is if you go to FedEx, it's almost Christmas time, and you drag a wagon of stuff into FedEx, bikes and toys and iPads, what's the first thing they're going to ask you to do really loud? Put it in a box. No one cares about the loose items. We need them to be packaged in a way that the rest of the system can fully automate itself. So let's look at what happens when we put this in a box. All right, so here we go. So we're going to think about this differently. We're going to give our applications shape, and once we give them shape, we can reason about them. So once we can reason about our application, we can start to do something slightly different. We can start strategically placing them in our clusters, okay? So what I'm doing here is a technique called bin packing. You'll see tools like Kubernetes do this. Oh man, this may not be a very good game. I know you guys are like, wow, he can talk and play Tetris at the same time. It's like, totally. So this idea of bin packing is we want to take our workloads and examine every piece as it comes into the playing field. Now, if we do this, wow, man, I'm like, where do I place these next pieces? So Kubernetes is doing the same thing. So we're placing these workloads all over our cluster. Oh, no, I don't fail. Come on. And you can imagine leaving space on one of the special machines. This is the machine that has the GPU of the very expensive machine to run. We can allow that particular workload to land on that machine. And guess what the magic is? Once that workload is complete, we can reclaim all the memory and CPU and return it to the system. Hell yeah, you can clap. All right, so now that we have this smart system in play, we're no longer going to copy binaries to a single machine. We're going to take a collection of machines, make them look like a single machine. We're going to use a bit of software in between to give and describe our workload, and it will do the placement for us. Okay? So what we want to do now is start to give these things shape. The first thing we need to do is build a container image. I'm not going to do this now, but here's what it looks like in my world. So that compilation step, this is a new feature inside of something like Docker. You can actually use other tools to build this stuff. So the first thing I'm going to do is the similar command that I had earlier, build the binary. And if you notice, I have this second step underneath where I take the built binary and I put that into a package. And this is the trick to make your packages really, really small. Right? So now that we have shape, these are going to define the shapes that we're going to give to our scheduler, which is going to be Kubernetes. Again, all open source. And then we have to do one more thing. We have to describe to Kubernetes what our shape looks like. So this is what we call a deployment config. We can tell it things about how it should update things. We can also give it a name of what we would like it to deploy. So this is like dropping a piece into the Tetris playing field. Once it sees the piece, it knows how to place it on one of the 10 servers that are running in my infrastructure. So what we're going to do now is tell Kubernetes to run this thing for me. And then we're going to tell it to just do this apply. All right, so what we're going to have here now is our application running in our cluster. We'll do this command. So we have one of them running. Now, the nice thing here is once it's running, we can communicate with this. I'm going to speed up a little bit because of time. So once we have this running, we can actually start to communicate with it. Once I get things working. And you guys are like, he's going to fail. No, I'm not. I have lots of confidence. All right. The demo gods are like, you tempted me too much. I'm going to recover, I think. Let's try this. Hold on. It's just warming up. I was sitting there for a while. All right, let's check on something really quick. So also, when you're doing live demos, it may not work. What you do is pretend like it was supposed to happen, and you keep going. You just talk through it. All right, let's see if we can figure out what's going on here. All right, let's look at this, look at this. So none of these things are healthy. All right, let's see. Ooh, I'm back in business. I'm back in business. All right, so our app is deployed. So the nice thing now is we can actually start running more commands to scale this up. But now we're in this world of abstractions. You notice we're not copying things to servers anymore. We didn't even pick the server where this will run. We now have a way of describing what we want. We're one step closer to this world where maybe we don't type commands anymore. Wouldn't it be cool if you can like talk to it and just say, deploy my application? How many people wish we could just do that? Right? Like this is so old the way we do things. So I have this little prototype that I built. We're going to try to see if you could do such a thing. Because I think the technology is there. We just have to think a little differently about how we approach these problems. So we're going to try it. So hopefully my phone is on. You can hear it. Let's try it. OK, Google, talk to container engine. Uh-oh, AV people, this is going to be on you. This is all you. Going to try it again. I like to blame people during my postmortems. OK, Google, talk to container engine. I'm going to give you one more try. You guys ready? Not you guys. OK, Google, talk to container engine.
Sure, getting the test version of container engine.
Hello, Kelsey.
Hello.
It's nice to be here at All Things Open. This is a pretty large crowd you have here. I noticed you're using conference Wi-Fi. The demo gods won't be too happy.
Scale the Hello World deployment.
How many replicas?
4.
Scaling the Hello World deployment to 4 replicas.
So, as we close out, it's easy to like bring things up and down. Now the Holy Grail, and this may not work perfectly, we got some Wi-Fi going on, but imagine if you can just tell it to update the application in place, okay? So I have version 1 of this and version 2 stored as a container, so what I would like to do now is just ask the system to just upgrade it for me, right? There's no need to update new commands, so let's try it now. Update the Hello World deployment.
Updating the Hello World deployment to version 2.0.0.
I gotta see it work first. Awesome.
I gotta admit, that was pretty dope.
And with that, I'd like to end the presentation. Thank you.